So this is part 2 of lesson 3 to keep the videos under 15 minutes. So I'm on the bottom of page 89 and I'm just looking at the policeman. The policeman gives me some nice notes. Here the policeman says, if I replace y with minus y, then my original function becomes negative y, or negative 1 times y, which is equivalent to y equals minus f at x. This is the replacement we've been doing on page 89, which is a mirror in the x-axis. So my mirror is equal to the x-axis, and you'll notice there's a nice opposite like we're used to. When y becomes minus y, we're actually mirroring in the x-axis. So if we go to the bottom of page 90, we've got that same policeman talking again, and he's making the same conclusion. If we replace x with minus x, then the function notation becomes f at minus x. This replacement is the example we looked at here, and this results in the mirror being the y-axis. So my mirror is on the y-axis. Again, a nice opposite relationship, similar to what we were used to with the translations that we were working with. There we go. My voice is better. The policeman on the next page, page 91, addresses inverses, and we're used to inverses already. Inverses take x and replace them with y and replace them with x, and the mirror line is actually that line y equals x. So we get to practice some double translations next. My orientation got fixed a little bit. We'll keep going. So some nice language to nail on your study sheets. A reflection is a transformation which reflects or flips a figure about a line. I've been talking about the mirrors that are there. Fill in the following blanks. A reflection in the x-axis. If I'm reflecting in the x-axis, what am I doing? I'm doing something with y. I'm doing something with y. Y becomes negative y. If the graph of f of y equals f at x is reflected in the, what is it reflected in? It's reflected in the y, reflecting in the x-axis. My orientation is still not nice, but this is a reflection in the x-axis, so that's the first blank. Then it is a graph of y, it's the graph of not minus y. If I reflect it in the y-axis, then my x is becoming minus x. It's a reflection in the y-axis, and I'm getting a graph of y equals f minus x. Y equals f at the function of minus x. And if I reflect it in the line y equals x, it's reflected in that same line, so the line y equals x. Then it's the graph of the inverse. And how do we show inverse notation? F to the minus 1 of x. So the policeman has some nice notes. We've talked about them already. Highlight those for yourself. Replacing x with minus x is a reflection in the y. Replacing y with minus y is actually a reflection in the x-axis. And then the exchanging of x's and y's results in an inverse. So try your hand at reflecting. I'm not going to try and plot these. Y equals minus y. That's a reflection in the x-axis. So reflect in x. You can see how crazy that is. As soon as I go y equals f to the minus x, that's going to be a reflection in the y-axis. And you can guess that the next graph is my inverse notation. So I have to take x and make them y, and y and make them x. So the x's and y's shift identities. The y becomes x, and then I can replot those graphs. One more set of graphs to inspect. So you can plot those points. You'll find those answers plotted also in your answer key. What's happening with these graphs? Take a look. Taking a look at the graphs below, I can see a nice inverse relationship. If you draw in the line y equals x, you'll see how that thicker line is related to the thin line. In B, the mirror nicely sets up along the y-axis. If there was a mirror on the y-axis, you would get that reflection. So the points just flip over the y-axis. And in C, it's the reflection in the x-axis. If the mirror was on the x-axis, we would get that reflection down from quadrant 1 to quadrant 4, and from quadrant 3 up to quadrant 2, the graph orients itself in the reverse order. Now we're going to try a double set of reflections. So now we have to do two reflections, both a reflection in the x-axis and a reflection in the y-axis. And what we need to know from the beginning is order does not matter. So you can reflect in the x-axis first and then in the y, or flip it around. So we've got a nice set of graphs done for us first. They first made y equal to minus y. So that went from graph A to graph 1. And then they reflected in the y-axis, which took graph 1 and turned it into graph 2. So we've got this graph that switches from position A to position 1 to position 2. We want to try that with in the opposite order, trying to prove that order does not matter. So reflecting in the y-axis, remember x has to take the place of x, and minus x has to take the place of x, and reflecting in the x-axis means that y is going to get replaced with minus y. So track those reflections. What happens when I reflect in the y-axis? So when I end up with that reflection in the y-axis, I end up with a mirror image somewhere in this zone. And then when I reflect in the x-axis, I end up flipping it around, and it does something like that. So I go from A to 1 to 2. Before you go on to our lesson in lesson 3, it would be good to play around with part 2, which deals with inverses. I'm interested in your conclusion about inverses. And the question is, does order matter? So I'd like you to run through this exercise. Try not to look at the answer book. The answer book does set up the diagrams, but follow the instructions. Reflect in the y-axis, then do the inverse, or do the inverse and then reflect in the y-axis. See if the graphs are the same, and then repeat it with reflecting in the x-axis and then doing the inverse. The assignment is on the pink page. I'm going to stop there for lesson 3 and pick up lesson 4.